If you've been around the labor force long enough to remember the days before the coring drill, you probably don't have many fond memories of working with a chipping gun to make holes in concrete. The tools were tough to use and control, and you often ended up with rough, misshapen holes. Or worse, you hit a section of rebar. Well, thanks to the core drill, those days are over. The core drill makes neat and clean holes through concrete, asphalt, and rock, whether they have reinforcement steel or not. The coring bits come in all sizes, ranging from 1 to 60 inches in diameter. But no matter what tool you're using, you need the proper personal protective equipment for the job, and you need training. With the proper guidance, a core drill is not a difficult tool to operate. But like any other tool we use, if you don't use your head while you're using the tool, somebody's liable to get hurt. And that somebody could be you. Successful drilling starts at the very beginning of the process. The first step is to look over the area where the hole will be drilled. Be sure to mark the center of the hole area and use the following drill setup procedures. The core drilling base. The column should be rigid to the base, with no movement. Rack gear should be tight to the column post, with no movement. The base leveling screws should be adjustable, clean, and lubricated. The core drill carriage should fit snug to the column, no excess play or movement. Should be keyed to the motor base for accurate alignment. Rack gear should be working smoothly and not missing any teeth. The core drill motor, on and off switches or valves, should be in proper working order. Alignment to the column has to be accurate. Water swivel or jacket should not leak. For bits, adapters, reducers, and extensions, make sure that all adapter threads are in good shape, cleaned and lubricated prior to connecting them together. Here are some of the common tools needed for coring other than the core drill. Before you prepare the setup, make sure the power to the core drill is off. Lay out the diameter of the hole from the center point for the perimeter location. Provide the exact location of the core hole prior to drilling. Lay out the holes for mounting the base anchor. Drill and set the anchors where needed to secure the base to the drilling surface. For maximum strength, clean out the hole prior to setting the anchor. Then, set the anchor in place. It is always a good practice to test the strength of the anchors to make sure they will support the core drill system through the drilling process. Screw the threaded rod into the anchor to mount the base to the drilling surface. The threaded rod should extend above the base a minimum of 2 inches. Mount the base of the drill to the drilling surface and snug with a hold-down plate, washer, and nut. Leave the nut loose at this time for later adjustments. Use a level and the leveling screws to align the column. Mount the drill motor and carriage to the drill column. If you're drilling vertically, this step is usually done earlier. Snug the carriage lock screw to the column while screwing on the core bit. Loosen the carriage lock screw and lower the drill motor to the concrete surface. Make any final adjustments by lining the drill spindle with the center hole mark. Tighten the hold-down plates to secure the base to the drilling surface. Retighten the hold-down bolts. Make sure they are secure. Plug the unit into the power source and water supply. Always use the GFCI when working with electrical tools and equipment. Select the correct RPM range for the bit's diameter and the material's hardness by checking the manufacturer's recommendations. After selecting the right bit, screw it on the drill motor spindle and tighten down until it is securely fastened. If the bit is longer than the thickness of the concrete, it is good practice to place a depth mark equivalent to the thickness of the concrete on the bit to let you know when you are about to drill through the back side of the concrete. Purge the water first, then adjust the water flow as required to produce gray water slurry, or a loose thin paste, during cutting. Ease the core bit into the surface and be sure the bit stays on the mark. Abrupt contact with the surface of the concrete will cause the bit to chatter. This can damage the cutting edge and cause movement of the bit. Apply pressure to the bit as required to allow it to drill smoothly. Keep constant pressure on the bit, allowing it to cut, and the motor to run freely without excessive strain. Constantly monitor the water flow to the bit. Too little water may cause cutting slurry buildup at the bit crown. This can restrict bit rotation and bits pull out. Too little water may also cause heat, which can cause glazing and core barrel flaring. This usually results with the bit sticking in the hole. Too much water may cause added back pressure against the bit, forcing the operator to apply more pressure to drill effectively. This can cause additional strain on the drill. Too much water may also cause excessive wastewater and added cleanup time. Continue drilling to the desired depth. If you encounter reinforcing steel while drilling, follow these steps. Reduce the pressure and RPMs. Increase the water flow to keep the cutting surface cool and free of steel shavings. Give the diamonds time to cut through the steel. Do not force the bit. Now that you've drilled a proper hole, let's talk about removing the core. For vertical holes, reduce the water flow for the last ½ inch of drilling, and the core will normally come out of the hole with the core bit. For horizontal holes, if the core does not come out with the drill bit, you can use 2 screwdrivers to wedge in the cut at the core sides and pry it out. The method used to remove cores will vary depending on the specifics on the job site. The supervisor will instruct the workers on the best method to use. When coring is complete, break down the drilling assembly. Clean and store the assembly components and clean up your work area. Always refer to the operator's guide if you are unsure of any operation and/or maintenance procedures for the type of coring system you are using. The core drill is a great tool for making clean holes in concrete. With a little practice and by following safe operating procedures, it can make your work life a lot easier.